Experiment 7 is about column and thin layer chromatography. Objectives of the experiment are to separate, purify, and identify components of a mixture composed of ferrocene and acetylferrocene, to determine the percentage of each component in the mixture, and to determine the effect of changing solvent polarity on the separation of the components. Components of the mixture are ferrocene and acetylferrocene. Ferrocene is the yellow band, while acetylferrocene is the orange band. Acetylferrocene is more polar than the ferrocene because of the acetyl group in the side chain of the molecule. Structure of ferrocene. Ferrocene is a sandwich organometallic compound containing 2 cyclopentadienyl anion, which is an aromatic structure, and an iron plus 2 as a central atom. It is called an organometallic compound because it contains an organic structure and an iron plus 2 as the metal. It is a sandwich compound because you have 2 cyclopentadienyl anion sandwiching the iron. The formula is given below. It's iron and 2 of C5H5, which is the cyclopentadienyl anion. The organic structure is a cyclopentane with 2 alkenes in the ring, and then this carbon having an extra electron. That's why it's negative. You can write 2 more structures, and these 3 structures are called resonance structures. You can represent these 3 structures as cyclopentane, and then a ring, or a circle, and a negative charge. Iron is plus 2, and the cyclopentadienyl anion is -1. Above and below, also -1. Therefore, the whole molecule is 0 charge or neutral. The procedure, we start with part A. I'm going to pack the column, and then we're going to be doing column chromatography. So we start with the micro kit. So in the micro kit, you will get a column, and this is longer than the column that we use for the distillation, for the fractional distillation. So this is longer, as you can see. Okay. So in the micro kit, you have this column, and then I'm gonna get the a plug. So this little guy in here. So I'm gonna put it over here. Okay, and then there's a little stopcock, so it fits right there. Okay, and then we also need a little funnel. It's gonna go up here. So that's the setup. It's a little bit flimsy, so you have to hold this when you're turning it. So if it's perpendicular, that's closed. If I have it straight, that's open. So, beginning, I'm gonna go like this. Okay? Alright. So I'm going to attach it here. So I have a stand, and then I have a receiver. Okay, so all the things that I need are already, I have it in the tray. So I should have the tip a little bit below the mouth of my e-flask, and I should not have it like way up here. Okay, so I want it, so I don't spill anything, I want it a little bit below that mouth so that I can also take it out easily. Okay, and I have a white paper here so you can see the contrast. So we have the solvent in here, and then I'm gonna packet this column with alumina. So this is the alumina, 80 to 200 mesh. And then I have the sand, I have the sample, and then receiver, the flasks. Okay, so for now I'm gonna set this aside. Okay, and then I'm going to pack the column. So next is we are going to weigh alumina. So this is the alumina, this is the adsorbent, and this is the stationary phase. So we're going to do column chromatography first. So I'm going to weigh 4.5 grams of the alumina. So I already tiered or zeroed the weighing boat. And then I'm going to weigh 4.5 grams. So now I have 4.504 grams of my alumina, so it's okay as long as I know the weight. Okay, that 0.004 doesn't matter really that much. So now I have 4.504 grams of alumina. So now we're done with this. Okay, and now I'm gonna take it out. We need to get the weight of 2 e-flasks because this will be our receiver. So actually this one is marked as an X. So this will be our first flask. There's an X. So right now the balance is 0. Okay. So whatever the weight is going to be the weight of the flask. So I will put the flask inside. Okay. Mark with an X. So now the weight right now, so write this down please, 38.727 grams. So the weight of the flask, mark with an X, is going to be 38.727 grams. Okay, so I'll take that out. And then I will have another e-flask. Okay, so it's 0 right now, so I don't have any mark in this one. So I'm gonna put it inside. And now the weight is 32.442 grams. Again, 32.442 grams. Okay? So I'll take that out. It's gonna be a receiver. So this is now our column. We're gonna put first the solvent, which is petroleum ether. So petroleum ether is the first solvent. I'm gonna put halfway. All right. So I'm just gonna use the pipette. So as a note, when you have organic solvents that are actually volatile, when you are using a pipette bulb like this, you have to saturate this with a vapor. Otherwise, when you put it in, when you withdraw a sample or a liquid, it's gonna squirt out because it's volatile. So the way to do that, so you can hold it, it doesn't drip. So right now it's still dripping, is you saturate it That means that you pipe it up and down several times, and then it will hold it. It doesn't drip, okay? So now I'm going to add here. So I now added petroleum ether halfway in the column. So I added petroleum ether. And then I'm now going to pack with the alumina. So this is the alumina that we weighed, 4.5 grams. So I'm just going to slowly add it to pack it. And then because this is dry, this is actually an adsorbent, it sticks to the top, right? So one way to do that is I'm going to use a stick, a boiling stick, okay? And I'm going to push it like that, right? So now I continue to pack. So I have 4.5 grams total. Okay. The other way is I use this, it's like an adapter, and then I try to like bang it gently, okay? Or the other way is I can moisten it. Like that, okay? But then slowly pack it. So it should pack, try to pack it as evenly as possible. So now you can see that it's packing. Okay. So this is the adsorbent. The stationary phase is the alumina. Alumina is aluminum oxide, Al2O3. So notice that if I just dump everything, it's just gonna accumulate on top. So I don't want to do that because I ended up, you know, stuck. I ended up the alumina stuck in here. So I have to push it, okay, like so. And then do again. Okay. So. Right. So note that I don't want it dripping on the side. That means that there's a leak. Okay. So as you can see, there's nothing going on, right? There's nothing going through. Okay. So now, again, I push it. Okay, it's just the stick, the boiling stick. And now, because I'm to the top of my solvent, I'm gonna add a little bit more of that petroleum ether. Okay, and then again, I'm gonna put everything. Right? Okay. So I put all the aluminum oxide, and again, I need to kind of push it to the bottom. But I'm not touching the top because I want it to be as evenly packed as possible and not disturbing my my column. And the whole point is I don't want air to be trapped in my column because it will, my separation will not be very good. So I try to make it as evenly packed as possible. Okay, so then I'm going to kind of rinse out so that all the alumina goes inside. So take note that the aluminum oxide is actually heavy, and stationary phase, so aluminum oxide is ionic, it's not dissolving in the solvent. So you can see that this part here is clear, and my aluminum oxide did not dissolve in the solvent. So it should be settled by now, okay? So the top one, so basically this is our area we're going to have the separation. So the whole point is to separate components. So I'm now going to put a little bit of sand. So the sand, the purpose of this sand is to make that surface, the top one, as even as possible, and it acts like a cushion, so that when I introduce the sample, their solvent, I don't disturb this part of my column or the alumina or my stationary phase. So I'm gonna put just like a centimeter or so of the sand. Okay, so this is the sand. This is the same sand that we use for a sand bath. This is the same sand in the ocean, in the sea. Lake Michigan is the same. Okay, except that this is washed. Okay, it doesn't have a lot of the, some salt in there, so it's washed. They call it sand washed. Okay, so this is the sand. So I'm gonna put it on top. So I'm just gonna scoop a little bit of it. All right, and then put it. So I did not really weigh it. I don't have to weigh it. So gently. Okay, so the purpose of that again is to act like a cushion. So I want it to be as even as possible. I'm just gonna tap it a little bit. Okay, okay, so now you can see that that's my sand, this is my stationary phase, and that's my solvent. So now, as you can see, this is my stationary phase, this is my liquid, that's the sand. Okay, so again, the sand did not dissolve, all right? And my solvent is the petroleum ether. Okay, so now that's my setup. Okay, so the next thing that we're going to be doing is, so I leave it like this, is typically each student will have a setup like this. So this is in fact given as an unknown. During the semester, each one will have an unknown sample like this. It's numbered, and each sample will have a specific amount of combination of two components, and that would be ferrocene and acetylferrocene. So you are trying to separate two components, ferrocene and acetylferrocene. So say I'm doing unknown number 29. The other purpose of the experiment is to determine what is my composition of my unknown 29. Okay, so when you're doing chromatography, you cannot overload your column, otherwise you don't get any separation. You can underload it, that's okay, but overloading is not acceptable because you will not achieve good separation. So we're gonna weigh about 100 milligrams or less, okay, of the sample, and we are going to introduce it in the column to separate. This is now the sample, unknown 29, inside the balance, and the weight is 6.402. So it's the entire vial with the cap and then the sample. I'm now going to drain the solvent on top. So you see there's a solvent here, right? And I'm going to drain it. I will drain it just right on the top, at the top of the sand. Okay, so you can see that it's dripping right now. So slowly that level of the solvent is also going down. So it's gonna go down, and I'm gonna stop. I'm gonna close the stopcock when the level of my solvent is just right above the sand. I don't want this column to dry up, because that actually introduces air, and you will have air bubbles or air packet in your column, and it will affect your separation. So I want it to be wet with the solvent. So it's draining, and we are going to put the sample once I have it right on top of the sand. Okay. So now we are going to introduce the sample. So I'm gonna put almost all of it, but I want to leave a little bit of sample, because I want to check the TLC of my original mixture. So I'm just going to dump it here. So I left a little bit of sample. Okay, a little bit here. Okay. And then I'm now going to put few drops of DCM. So DCM is dichloromethane or methylene chloride. DCM is the abbreviation. And then I'm going to dissolve it a little bit. Okay, so again, this is volatile. So the way you use a dropper or a pipette, this kind of pipette, is you pipette up and down to saturate the bulb with the solvent, and then it will not squirt out. And then when you lift it, that solvent is not squirting out. Okay, so I'm gonna add a few drops to my funnel. Okay, so I let it settle down, dissolve a few seconds, and look that it's actually now going inside. Okay, now I'm gonna open this to let that solvent go through, but watching that I don't let this dry. So just few drops, because I just added few drops, right? Okay. So I close it again, because I can see already the sand. Okay, so I'm gonna do a few more drops, because it's still like, you know, I still see the color on the side here. Okay, so I added almost like close to 10 drops. Okay, so now, okay, and then I'm gonna watch that it doesn't go beyond the sand. Okay, close. Okay, now I'm gonna use now again the solvent that I used to pack it, which is petroleum ether. So look that if I don't saturate it, it's just dripping because it's volatile. So the way that I can control it is to saturate the top one by pipetting up and down, and then it stays. Okay, all right, so again in a circular motion. Okay, So I did not fill it up yet because I don't want this to be diluted. I want it to be as concentrated as possible when it's going through the adsorbent. So you can see that the solvent is still kind of colored. Now again, close. So I'm going to again, there is something stuck in here, so I'm going to lift it and then I will try to rinse it out. Okay. Okay. And then I'm gonna so I'm going to add more solvent now because it's getting clear. Okay. So I can add more of the petroleum ether. So right now I'm just waiting for the bands to come out. And you can see that there's like a yellow band in here. So that's the first fraction. And then we are going to put that flask with an X. It's the first fraction. So this is the yellow band. And right now I'm just collecting the solvent. And there's no color yet. So once I see the color touching, I can rotate this. Okay, so it's now close to the bottom, so I'm going to put these because it's starting to change a little bit. So now it's yellow. Okay. So I'm collecting now the first band. So I'm gonna put more solvent because remember I don't want this to dry up. So you can see solvent here. And then I'm going to just put more solvent, which is the petroleum ether. Okay. And take note that this, again, the solvent system is volatile. So you're gonna see it, the sample, so remember the sample is solid. We dissolve it and it became a solution. So when it's starting to come out, because the drop is not very fast, so it's gonna accumulate here. And because it's cold, it's evaporating, you will see it crystallizing here. So one way to do that is to rinse this out with DCM. Okay? So the yellow band, it's like there's now a space here. So that's what I want to see, is to have a space of white. So the yellow came out first and there's like an orange band up here. So I tried to rinse it with, again, the tip with DCM to dissolve it. And I just want to squirt it, but I don't want to touch the sample, otherwise I contaminate my solvent. So if I take it out, you can see if I rotate it, okay, So I have the yellow band came out. I'm collecting it right now. And then the orange band is left behind. So this is basically what is called descending chromatography. That means by gravity, the solvent pulls the component to the bottom. So you have three things going on here. So let me put more solvent. So three things. You have the sample, you have the solvent, that's the mobile phase, and then you have the adsorbent, which is the stationary phase. The stationary phase doesn't move, while the mobile phase, which is the liquid, is moving. That's your mobile phase or the moving phase. And my sample is interacting with the solvent and the stationary phase. So depending on the structure of my component, either it's going to travel fast or slow, because it's bipolarity, the way it's interacting with the stationary phase. So the sample gets separated because of its interaction with the stationary phase and with the solvent. Okay? So now I have to rinse a few more times the tip. So it's now getting lighter and I don't see a lot of the yellow component anymore, the first band. So this is basically our first band, and that's gonna be labeled with X, right, that we weighed the flask. Okay, so right now, because the second component, the orange one, is not moving as fast. Okay, so I now have a white band here, which is now we're back to the alumina. So we're now done with that first band, which is the first fraction, and I will now change it to just a waste container here. But this is our first band, so I put it here. All right, and now we are, because it's very slow, right? It's sticking to the column. I will change the mobile phase to a combination of petroleum ether and diethyl ether, 1:1 mixture. So I'm now going to put, so again, pipette up and down to saturate it, otherwise it squirts like that. So saturate up and down. Okay, several times. And then the other technique too is don't go so far when you're going to transfer, go close so that it's not dripping all over. Okay? Okay? So now I'm going to again let it drain. So I now change the mobile phase, and typically when there's a change of mobile phase, there's like a heat generated, there's a heat of mixing, and you can see that I get a little bit of a separation of the alumina in here, but that's okay because I don't think it will affect my separation a lot because I was already able to separate the yellow band. So I just got a cork in here, so I'm just gonna cork this so I don't have anything, any particulates that go into my sample. So So I can add more of my mobile phase. So right now we're just watching this to go through. So it's moving slow, but we should be able to collect that orange band. The orange band is now down here, so I'm now going to change the receiver. So this is the pre-weighed flask that we weighed earlier, and now the orange band is now down at the bottom. You can see here. Okay. So again, because both of these are volatile solvents, petroleum ether and diethyl ether, it will also crystallize when it's going through, because the it's not fast enough, the drops, and that sample, which is a solid, will start to crystallize at the tip. So I'm going to rinse it again, so I have to watch for it. I'm going to rinse it again with dichloromethane, which is DCM. So this band is orange, the first one is yellow, and so as you can see, I don't see any more any yellow here, nor there's a slight like orange band around here, but all the yellow, or all the yellow came out, and now it's the orange that's coming out. So I see some crystallization at the tip. So again, I'm gonna rinse it with DCM. So again, pipe it up and down, and then slowly rinse the tip so that it goes to the flask. And then I have to watch that this one doesn't dry up, so I can add more of that mixture, solvent, petroleum ether, diethyl ether. Okay. So this is the second band, or the so fraction 2, which is the orange band. The first one was the yellow band. So this also means that the first band is moving faster, so it's not sticking to the column. However, the orange band is sticking more to the column. That's why we have to change the mobile phase to a more polar solvent, more polar mixture, so that we can move it. You can still use that petroleum ether, the first solvent, but it's gonna take forever. It's gonna take longer for it to go through the column. So that's one technique to make it move faster, is to change the mobile phase. If you start with the petroleum ether, diethyl ether mixture, if you start with this, you cannot go back. That means that if you use a more polar mobile phase, you cannot change it to a less polar mobile phase. So you start with the less polar and then change it to a more polar mobile phase. So as a note here, the alumina is actually polar. So this is called a normal phase chromatography, wherein the adsorbent is a polar stationary phase. So again, DCM to rinse out the tip. So it doesn't crystallize at the tip, otherwise it grows like a balloon, it's crystallizing, and will absorb also moisture. So we're almost done here, okay? So, so again, you cannot overload your stationary phase because everything will smear. And if it's overloaded, it will also cause tailing, and then the bands will overlap. That means that the yellow and then the orange band will overlap. You cannot achieve a good separation. So better to slightly underload, otherwise, okay, don't exaggerate too, because if you put a lot of the stationary phase and you only have very small amount of sample to separate, then you're also wasting your stationary phase. So it has to have at least like 50 times approximately, because we weighed about 4.5 grams, so it's about 50 times approximately the weight of the stationary phase, and then your sample. So now I'm gonna put more. We're almost there, so I think that should be enough. And again, rinse out the tip. So as you can see, this is the yellow band, that's the orange band. So take note that what's in here is the sample that's colored orange, and then we have combination of 3 solvents: petroleum ether, diethyl ether, and then DCM. Those solvents will evaporate, so what would remain after we heat this up is just going to be the orange component. And the same thing that will happen here. So we have, again, because we rinse it out with DCM, you have petroleum ether, DCM. So after we evaporate the solvent, what remained in this flask will just be the yellow band, the yellow component. So I think once this touches the sand, we're gonna stop it, and then we are now going to evaporate this to dryness on a hot plate. The vial containing unknown 29 is inside the balance, is on the balance, and the weight is 6.308. And remember that we had a weight of this before we put the sample in the column. So this is the weight. Subtract this weight from that original weight, and that's going to be the weight of the sample that we put in the column. So again, the weight now is 6.308 grams of unknown 29. The sample on the left is the yellow band. Sample on the right is the orange band. So I have a boiling stick. So I'm now evaporating the solvent. So I just set it to about 30 because it's low boiling, and I want to control the heating. So I put the boiling stick. So you see the bubbles near the boiling stick. So it should evaporate fast. Okay. So this is now, we're just getting rid of the solvent. So what would remain is a solid. because remember the sample that we put is a solid, so obviously we will have the sample as a solid. So after this evaporate, so it's now a solution. The sample is dissolved in the solvent. So after we evaporate this, it will just be a solid that would be in the flask. This sample is the yellow band, and it's dry already. And then this is the fraction orange, so I'm gonna label this as fraction yellow. I also put the weight of the flask, so that's 38.727 grams. And then this one is the weight of that flask, 38.442 grams. And we're gonna leave it drying more for another week or the next lab period, and then we are going to do the second day experiment, which is going to be the TLC or thin layer chromatography, and then the melting point determination. So that's it. This is the yellow band, that's the orange band. The samples were dried after a week, so this is the yellow band and this is the orange band. And I had it slightly, I did not tighten the cap or the cork so that the samples can dry more. So now I'm gonna cap it later, but I'm now going to weigh these two samples. Okay, so remember the flask with the first fraction has a mark X. So I'm now going to weigh it. The weight is 0 right now. So I'm now going to put it inside the balance. So take down the weight, please. So it's 38.755 grams. Again, it's 38.755 grams. And now I'm gonna take this out and then label again with the yellow. And then now I cork it. And now I'm gonna do the next one, which is the orange fraction. So I'm gonna take out the label because we did not really weigh this label. Okay, so again 0. So this is the second fraction, and now the weight is okay, so the weight of the orange fraction plus the flask is 32.459. Okay, so now I'm gonna take it out, and then so two things that we're gonna be doing would be to take the melting point of each of the fractions, and then we will also do the TLC or thin layer chromatography to determine the purity of the sample. So both techniques, the melting point determination and then the TLC, will determine if both samples are pure or not. So thin layer chromatography or TLC is a method to identify or determine the sample if it's pure or not. It can also a way to determine the identity, so as long as you have a standard. Now from the experiment that we had, the column chromatography, remember we already weighed the dried sample, which is actually, this is the yellow band and this is the orange band, and then it's dry already. And as you can see, I scrape the bottom with this boiling stick, and you can see that they're now crystalline. Okay, so I'm gonna take out a little bit of this sample and put it in the tube, but I'm gonna show you that the other sample, I also scrape it just using the stick. Okay, so the orange band is now a solid. So then I will put a little bit of that sample in a tube. So this is a medium-sized tube, and then I'm gonna put a little bit of that sample. So the other way to do it is I have a spatula, okay? Then I'm just gonna scoop a little bit of that sample. Take this out, put it here, and then I'm gonna just scoop a little bit. And I want to have enough sample for the melting point, so that should be enough for the TLC. So I have the tube, and then you see the bottom, some of the sample, which is the yellow fraction. And then I'm gonna be doing the same thing for the orange band. So now this is the orange band. I'm gonna use a scoopula to take out some sample, and then again put it in the tube. Okay, so I have now this tube. Okay, so I have the label red. Okay, so now I have the other sample, which is the original sample, and I already put, so remember the 29 unknown, and then I already put a little bit of sample in this tube here, right? So we have 3 samples. So now we did column chromatography, and then so that column chromatography is enclosed. However, for the TLC, so this is the silica gel thin layer chromatography. It actually has an indicator, so I'll show you how it looks like later on. And then, so it's kind of the same idea, sort of like a filtration kind of thing, but this is now going the opposite direction. So the column was going down, right? This one is now going up, it's ascending. So the same thing, we have so I took out one of this plate. So the plate has a silica gel this time, okay, similar to aluminum oxide, but this is the plate. So the back side is plastic, it's actually shiny. However, this one is kind of white stuff, but it's not shiny. So this one is plastic, okay, but it was coated on this other side. So don't touch the side that is kind of rough. You can touch this part, but not this side. So we're gonna put the sample in here. So this is the stationary phase, the silica gel, and then we're gonna put that in a jar. So the jar contains the mobile phase, the solvent. So I already made the mobile phase, which is 10% ethyl acetate or PET ether, petroleum ether. So approximately you can make like 5 ml or 4 ml or 3 mls. But I made 5 mls because it was just easier. So to make a 5 ml solution, you put 0.5 ml of the ethyl acetate, and then you volume it to 5 ml of PET ether. So I use this, all right? I use a graduated cylinder, and then this is ethyl acetate solvent. So that's the first solvent, and then PET ether or Ligroin is the second solvent. So I use this measuring pipette. It's like 0.5 ml up to this mark here, and then I put it in here, and then so it's like half a ml, all right, and then I volume it to 5 ml. So that's going to be 10% of ethyl acetate in petroleum ether or Ligroin. So that's our mobile phase. Okay. So again, there are 3 things happening. There are 3 components. Your sample is going to be, you have 3 samples, the fraction, yellow fraction, orange fraction, and then the original one. And then it's going to be interacting with the stationary phase, which is the silica gel. And then you have also the mobile phase. So the sample will interact with both the stationary phase and then the mobile phase. And then depending again on the structure, one will be moving faster than the other. So that's what we're going to be observing in the TLC, which is thin layer chromatography. Okay, so now there is a height. So I lightly mark this with a pencil. Don't mark it with a pen because the pen will stain. So I put a mark, actually lightly mark it at the bottom, this one. So it's more than a centimeter. Okay, so I use this one. Okay, so it's about between 1 centimeter and 1.5. So I put like 1.3 mark. And then how did I figure that out? So I put in the jar about 3 mils of the mobile phase. So the height, so you see the level, right? So the height of that solvent should be below the height where I start, or the origin. So if I use this, so this is the plate, and then that's the height of my solvent. I should not start where I spotted below the level of the mobile phase, because it's going to dissolve into the mobile phase. I don't want to do that. So basically, I start, my point of origin should be above the level of my solvent. Okay? So approximately 1.3 centimeter is where I start spotting. So the next step is I'm going to dissolve. So I cannot really just spot this because it's a solid. So I have to dissolve it with DCM, with dichloromethane. So I put it in this tube. You can use a spot plate, but the spot plate, the solvent will evaporate fast. So I'm using a tube, a test tube, so that it doesn't evaporate as fast as possible, because I might have to redo the TLC. Okay? So now I'm gonna put a few drops, just like 1 or 2 drops, 2 drops to dissolve. So I think I added like 5 drops, okay? So now you can see that it's yellow, all right? So I'm gonna do the same thing for these. So I'm gonna do 5 drops. So you see that it is orange. That's the orange band. And then our original sample is in here. So I'm gonna add 5 drops again. Okay? So that is the sample, original sample, which is unknown 29. So now I have it dissolved. So it's now in solution. So the DCM doesn't really matter. You can use another solvent as long as it dissolves. Okay, so I'm gonna spot in this plate. So again, I mark it with a pencil, with a ruler, about 1.3 centimeter from the bottom. So I'm gonna start at this side. So now you spot it so that you don't want the spot to be too close to the bottom or too close to the edge. Okay, so I'm gonna put it, so this can accommodate 3 spots. I have 3 samples. Okay, so this is my first sample. So I can just use this to spot. So I can do several times until I get a decent size of a spot. Because it's colored, I can see where I spotted it. Okay? So you can see that I have a yellow spot. Okay? It's in here. And then I'm gonna do now the orange band. Okay? So I'm gonna put it not too close to that yellow spot. So I now have 2 spots. yellow, and orange. And then the last one is going to be the original sample. So I want to compare the original sample with the fractions. So again, I'm going to put it beside it. Okay, so let's try these. So, all right. So it should dry pretty fast. So sometimes you can just air dry it. So I now have 3 spots, yellow, orange, and then the mixture. So now we're gonna dip it in this mobile phase. So once you dip it, don't try to move it around. Okay. So let it be, and you have to watch it that it doesn't go over. So you have to watch that it doesn't go over. So basically this is white. When it gets wet, it looks wet. It's like water going up. So this by capillary action, it's gonna go up because it's ascending. So this is ascending chromatography. So you're gonna watch it so that it doesn't go beyond. So the mobile phase should be like a centimeter before it reaches the top. Okay? So it should be dry by now, and then I'm gonna dip it. So because the mouth is small, so I don't want to like just drop it. I want to slowly dip it. So I'm gonna use a this forceps, okay? And then I'm gonna dip it, and then let it. So it's kind of lying on one side, okay? But I leave it. So as you can see, the mobile phase is going up, okay? So it looks wet, okay? So it's gonna go up, and we're gonna watch it so that it doesn't go over. So you can see already that the yellow is going faster than the orange. So which is the same thing as when we did the column chromatography. The yellow is moving faster, but it's going down. This one is going up this time. And then, so you can tell from this plate that my orange is a little bit more concentrated than my yellow. And my original sample is less concentrated. So now we can make adjustment. So what we can do is we can dilute the orange band. That means that we're gonna put more DCM. And then you can also adjust the original sample, which is the unknown 29, by putting more, by adding more. Or I can spot more. So there are ways to make it more concentrated so that the spots are almost equal in size. So it's almost done, so I'm gonna take it out. And you can see that the level is here, so I'm gonna mark it fast because it's gonna go, okay? It's gonna disappear, it's evaporating. So actually this is okay. All right, so you can air dry it, it will evaporate fast. And then I now have the yellow, there's another yellow in here, and this is gonna be my orange. So it's actually in the same lane, okay? So this is one lane, second, third, but you can see that it's on the same line, So that means that I have a pure yellow, pure orange, there's nothing behind. But as you can see, there's a little bit of a spot actually at the bottom. So this one is the orange, that one is the yellow. Okay, so I can now mark this. Okay, so I'm gonna mark it. Okay, so now you're gonna measure. We're gonna measure what is called the RF value. So the RF value is the distance. I'm gonna use this ruler. So the distance. So remember, we have this as our origin. Okay, so that's our origin. So the distance from the origin to the spot, okay, so origin to the spot is about 0.8 centimeter. So for the original one, there's 0.8 and there's also like 3.5. And then this is the distance from the origin to the spot, origin to the spot, origin to the solvent front. This is called the solvent front over here. So that distance is 4.70. Okay, so this one is the same distance, like 0.80, 0.80, and then this one is like 3.50. So there's no other spot in here. So this is the original, matching these, matching that, and you can see that there's a slight impurity or slight sample that actually stays behind, which is in the it's very light, that stays behind, that did not move. Okay, so this is our first sample, and then the mobile phase that I use is 10% ethyl acetate petroleum ether. So we're gonna do one more and see the comparison. If you adjust the ratio, so instead of using 10%, I can use 20%, or I can make it less. I can make it 5% ethyl acetate, but if I make it 5%, this will not move. If I make it 15% or 20%, this one will move faster, and this one is going to move faster too. So let's just try one and see how the effect. So I'm going to do 20% ethyl acetate petroleum ether. You know, when I use the flashlight, you can see the mobile phase going up. So I think I'm ready to take it out now with the forceps. Okay, so the mobile phase, you mark it here. Okay, and then it's gonna dry fast. This is a volatile solvent, so I want it to be almost the same height as the previous one, so almost the same height. So you can see that it moved faster. So this is now comparison of the 20% on my left. So there's 20% on my left and 10% here. So I'm gonna encircle the spot again to make a comparison. And this is actually that spot, the yellow, and then this one, and then here, and then this one. Okay. So if we now measure, so this one now becomes the starting point. So now I'm starting here, okay? I'm starting here, and this is the solvent front. The distance from the origin to the solvent front is now measuring as 4.50 centimeter. And then the distance from here to the spot is about, let's see, it's now higher, right? So it's now 1.70 for both, and then this one is about 4.0 for both. Compared to this one, it's less, it's lower. So this one traveled faster. So now, if you compare it, this one, if you increase the ethyl acetate, it traveled faster, more than the 10%. So this device is a UV lamp, and actually I turn it on to about 254 nanometer at the back. So there's a switch. This is the long wavelength, but this one is short wavelength. And then I put the two plates inside. I put it here underneath, and then you can see that the sample or the plate fluoresces. So the white silica gel has a fluorescent indicator. So this one is okay because the samples are colored. If the samples are not colored, the spots will will be indicated by the fluorescent indicator, and you can see the spots. I will now be doing the melting point determination, so I put in this cupcake container the yellow band solid, and then I pack it on the tube, which is open end, and this is closed end. Okay, so now I'm going to drop it into this tube. So this tube is a glass tubing. So remember, we did this in experiment 1, and this is the closed end, so I'm gonna pack it on the closed end. So basically I'm going to drop it, right? So this one is open, that's open, and then I'm gonna drop this here to the bottom to pack it on that side, which is closed end. Okay, so alright, so now I have the melting point capillary tube. Okay, so that's the yellow bands. I'm going to color code these. This is now the yellow solid. So I'm going to be doing the same now for the other one, which is the orange fraction. So I'm going to put here, okay? And then I'm going to get again one tube. So again, this is open, that's closed. So I'm gonna pack it on the open end and just kind of like put it in. And then, so gonna do it several times. And then you drop it again on this one. Go like that, okay? So that should be actually enough, but I want to make it almost the same height. So I put a little bit more of that one, but it's okay. So, one more time. Okay, that should be okay. Alright, so now I'm gonna put this here. Okay, then we're gonna do melting point. Last part of the experiment is the melting point. So I already packed it in the melting point capillary tube. This is the fraction orange, fraction yellow. The orange band melted at 84 to 85. Now this one, it hasn't melted, so I'm going to increase it. So I will stop, and then I will increase the plateau. So 172 is my setting. So the yellow band melted at 174 to 175, and our results for the melting point determination and the TLC should synchronize.